Today we're going to be talking about parallel lines and how they can affect the proportionality between triangles and other polygons. First, we're going to look at Theorem 7.5, which is the triangle proportionality theorem. It says if you have two parallel lines, BE and CD, then the triangle that makes up them, AB over BC, is going to be proportional to AE over ED. So let's look at that in an example. It says in triangle PQR, ST is parallel to RQ. So these two lines are parallel. Okay? We know that PT, this length, is 7.5, and we know that TQ is 3, and we know that SR is going to be 2.5. Find the length of PS. So this is X that we're looking for right there. Well, Theorem 7.5 said that those would be proportional amounts. It said that since we have two parallel lines, ST and RQ, that the long side, 7.5 over 3, 7.5 over 3, is going to be proportional to X over 2.5. Okay? So we cross multiply. 3 times X is 3X. 7.5 times 2.5. I'll do that on my calculator. And that's 18.75. So I divide both sides by 3. And I find that my X is going to be 6.25. So you see the difference between this one. It says that the sides are proportional. Notice they're not going to be equal. Alright, so the converse of it says that if actually these two sides are proportional and these two sides are proportional, then obviously these lines right here have to be parallel. So it's going the opposite way. So let's look at an example right here. It says DEF, EH is 3, and HF is 9. DG is 1/3 the length of GF. So this DG is 1/3 that. So if GF is X, then this is going to be 1/3 of X. Is DE and GH parallel? So what we can do is we can set up a proportion. We can say, well, 9 over 3, so I'm going to do long side over short side, is maybe proportional, put a question mark, to X over 1/3 X. Alright? So now to test this, we're just going to solve the proportion. 9 times 1/3 X and 3 times X. Well, the easy one, 3 times X, is just 3X. And now 9 times 1/3 is 3X. So notice those are the same. So are DE and GH parallel? The answer is yes. So you can write DE is parallel to GH because those sides are proportional. Here's a guided practice problem. Feel free to try this one now. So the next thing we're going to talk about is the mid-segment of a triangle. It's a segment so that the endpoints are the midpoints of two sides. So you have this one right here, this one right here, and this one right here are our mid-segments for our triangle because they're congruent on both sides. Okay? So there's a theorem that goes along with our mid-segment. It's Theorem 7.7. It says, a mid-segment of a triangle is parallel to one side of the triangle, and its length is 1/2 the length of that side. So, right here, if we have two parallel sides, okay, FG and JK, that means that JK is 1/2 of FG. Since we know that J and K are the midpoints, and this is halfway between here and halfway between here, then obviously this side is going to be half of the long side, so 2X and X. Alright, so let's use this information to try example 3. It says in the figure, XY and XZ are mid-segments of triangle RST. Find the length of each measure. So, first off, we're going to have to try and find XZ, this one right here. Well, we know that the whole thing RT is going to be 13, has a length of 13. And we know that XZ is the midsegment. Both X and Z are the midsegment. So these lines are going to be parallel. And since they're parallel, XZ is going to be half of 13. So we'd say 1/2 times 13 equals 6.5. So how long is XZ? It's going to have a length of 6.5. Okay, now let's find ST. I better write this in so I don't forget 6.5. Okay, now ST. Okay, well, if I know I'm looking for ST right here, ST right here. Well, I know that the mid segment right there is 7, and these are parallel lines, and so it's going to be twice as long as 7. So I'm going to take 2 times 7, and that's going to be 14. So how long is ST? It's 14. I'll write that down. Might come in handy later. Now the last one is to find the measure of angle RYX. So if I'm looking for RYX, I got to look for this one right here. Well, the nice thing is this, okay? We already said that RT and XZ are parallel lines. And we have this transversal XY that cuts it. So we learned back in earlier chapters that these two angles are alternating interior angles, and alternating interior angles are always the same. So the measure of angle RYX is going to have to be 124 degrees. Here's 3 problems for you to try in the guided practice now. Alright, so now what we can do is we can start finding some corollaries of our theorems. The proportional parts of parallel lines corollary, 7.1, says that if we have some 3 parallel lines right here, okay, then AB over BC is going to have to be proportional to EF over FG. And the reason that is because parallel lines never cross. So that means that this transversal AC and this transversal EG are going to intersect at similar parts. So if I look at this example right here, example 4, it says Megan is drawing a hallway in the 1-point perspective. She uses the guidelines shown to draw 2 windows on the left wall. If segment AD, BC, WZ, and XY are parallel, and AB is 8 centimeters, and DC is 9 centimeters, and ZY is 5 centimeters, find WX. Okay? So this just uses our corollary that we just talked about. And it said this, that WX over AB is going to have to be proportional to ZY over CD. So I set up my proportion like that. I cross multiply. 9 times x is 9x. 8 times 5 is 40. Divide both sides by 9. And find that x is going to be about 4.4 centimeters. Here's a guided practice problem that has to do with real estate. You can try this one now. Now, congruent parts of parallel lines. So, it says if we have 3 or more parallel lines cut off congruent segments on one transversal, then they cut off congruent segments on the other. So essentially it's saying I have these 3 parallel lines. Okay? Now, if I know that AB and BC are equal to each other, then I can obviously say that EF and FG are also going to be congruent to each other as well. So let's use this information to find our missing values of x and y. Alright, so we know that we have 3 parallel lines. Good. We know that MP and PQ are congruent to each other. Find x and y. So what I'm going to do is I'm going to say Well, I know that this is equal to this, okay? And so that's easy. It's actually easier to find y first. 3y plus 8 has to be equal to 5y minus 7. It's a moron problem. There's more y's right here. So I subtract 3y from both sides, and I get 8 is equal to 2y minus 7. Since all the letters are on the right, I'm going to move all the numbers to the left, add 7 to both sides, and I find that 15 is equal to 2y. Divide by 2, divide by 2, y is going to equal 7.5. So now, since we know that these are parallel lines, we can also obviously tell that JK and KL are going to be equal as well. So to find x, I set it up this way. Okay? So now I can subtract 4x from both sides, and I get 2x minus 5 is equal to 3. Add 5 to both sides, I get 2x is equal to 8. So x is obviously going to have to equal 4. So my two values of x and y are 4 and 7.5. Alright, here's some guided practice problems for you to try as well.